Assalamualaikum and hello everyone. Welcome to the video for chapter 1 reaction kinetics for 1.2 collision theory. In this video, we're going to learn to define activation energy, draw energy profile diagram for exothermic and endothermic reaction where we have to include the activation energy in the diagram, and last but not least to explain collision theory. Okay, so what is collision theory? Okay, collision theory is the theory to explain the rate of chemical reaction. So during 1.1, we have learned the definition of rate, whereby rate is equal to change in concentration over time. So for the change of concentration, it could be in terms of concentration or in terms of product. Okay, but for the collision theory, it is based on the ideas that first molecule must collide to react. And then the second one is that the collision involved must be effective collision. So here, the collision involved is effective collision. What is effective collision? Effective collision is a collision that leads to the formation of product. Okay, so based on the collision theory, we can say that the rate is directly proportional to the number of effective collision, but inversely proportional to time. Now we're going to look at what is the criteria of effective collision. So there are two criteria of effective collision. First one is that molecule must collide at correct orientation. So based on the diagram here, what we have on the reactant side is NO plus O3. So for the case of ineffective collision, where the molecule does not collide at correct orientation, we can see that for the reactant and the product is the same. NO plus O3 and NO plus O3 because the molecule collide incorrect orientation. This one is not the correct orientation one. Okay, but then, okay, for the bottom one here, we can see that when NO and O3 collide at the correct orientation, so it means that it undergoes effective collision, then we can see that the product is different than the reactant, where we have NO plus O3 will become NO2 plus O2. So for this molecule, since it collide at the correct orientation, so it means that it will be one of the criteria of effective collision. Hence, we will have a product. So we can see the reactant and the product is a different species. Whereas for the ineffective collision, there is no changes from NO plus O3 become NO plus O3. So there's no formation of product lah. So this one is ineffective collision. Okay, so that is the first criteria. The second criteria is that the molecule must have total kinetic energy equal to or greater than the activation energy. When we're talking about the collision of the molecules, so it means that the molecule have their energy or have the kinetic energy. But then the molecule itself must have the kinetic energy equal or greater than the activation energy. Activation energy, or the symbol is EA, is the minimum potential energy that molecules must possess to initiate the chemical reaction. During chapter 2, we have learned about the energy profile diagram for the exothermic reaction and endothermic reaction. Okay, and then when we're drawing the exothermic and endothermic reaction, you only have to label the delta H. Again, what is the delta H? Delta H is enthalpy, where there is the difference of energy between product and reactant. But for this chapter 1, since we learned about the definition of activation energy, when drawing the energy profile diagram, we have to label the EA. Okay, so what is EA? So here it mentioned activation energy is the energy barrier that must be overcome by the reactant before they can form product. So kita boleh assume energy profile diagram ni macam kita naik bukit kan. So ini adalah daripada reactant kita ke puncak bukit tu. Okay, so that is the activation energy. But no worries, we're going to look further during the next page. So on this page, what we have learned is about the collision theory, and collision theory mainly focus on the effective collision, where the effective collision is the collision that leads to the formation of product, and we have learned there are two criteria. And besides that, we also have learned the definition of activation energy. So next, what we're going to look at is actually what we're going to draw, the exothermic and endothermic reaction, okay, where we have to be specific, we have to include the activation energy or the EA. So now on page 10, what we're going to look at is actually on the energy profile diagram of the reaction. Okay, so this is a bit of recap of what you have learned during chapter 2 for the exothermic reaction and endothermic reaction. So let us fill in about the exothermic reaction first. So let's look for the exothermic reaction. So again, exothermic is actually heat released to the surrounding. So again, when heat released to the surrounding or the heat loss, so what happens is that the energy of product will be lower than the energy of the reactant. But then for this case here, energy of reactant is higher than the energy of product. So for the exothermic reaction, the delta H is negative. Again, why is it negative? Delta H is the when the product minus the reactant. Okay, since the reactant is a bigger number than the product, so when the small number minus a big number, hence you will get a negative value. So that is for the exothermic reaction. For the endothermic reaction, it is the opposite of exothermic reaction, where heat absorbed from the surrounding. So when heat is absorbed, so it means that energy of reactant is lower than the energy of product. Okay, why? Since we absorb heat or absorb energy, so that's why, okay, the product will have a higher value, okay, or higher energy. So again, delta H is product minus reactant. So this case product is higher than the reactant, so that's why the delta H is positive. So that is the recap from the chapter 2. Okay, but now for chapter 1, when we're drawing the energy profile diagram, we have to include about the activation energy. But there are two cases of activation energy. We have activation energy forward and activation energy reverse. Or when we label it, we will write down EA forward and EA reverse. Okay, but then how do we label EA forward? Okay, EA forward is a forward reaction again from the reactant to product, right? Okay, so this is the reaction kita. So the EA forward, okay, is actually from the reactant itself to the tip of the heel. So contohnya, we have two energy profile diagram kan. So contohnya if we have this one, okay, and then we have this one. Okay, so to the tip of reaction tu yang ni, yang atas bukit ni. Okay, so I'm just gonna label from the reactant to the tip. Whereas for the activation energy reverse is from product to the tip. Okay. So later on, we're going to label our energy profile diagram by using EA forward and EA reverse. So this is the new stuff that you learn in chapter 1. Okay, but then what we have learned during our chapter 2, we have learned the enthalpy or the delta H. In this case, delta H is from the product to the reactant. Or you could also show from the reactant to the product. It is the same lah. But then I use product minus reactant just to show, again, to calculate delta H is actually product minus reactant. Okay. But then for this chapter, actually you can correlate the enthalpy, the EA forward and EA reverse, where delta H is equal to EA forward minus EA reverse. So for this chapter 1.2, so this is the only calculation lah. If we have any calculation question where we calculate the delta H by using EA forward minus EA reverse. So for example, if the question give you EA reverse and delta H, then we can find the EA forward. Or if the question give you EA forward and EA reverse, you can calculate the delta H. Okay, so during chapter 2, we learn delta H product minus reactant. But for 1.2 here, actually we could also use delta H is equal to EA forward minus EA reverse. Okay, so that is the terms, the calculation and how to label it. So now let's label the energy profile diagram. Okay, again for the exothermic reaction, since energy of reactant is higher than the energy product, so when we draw the hill here, ataupun kita lukis kita punya bukit, kan? Okay, so again we need to have the potential energy as the Y and the x-axis is the progress of reaction. Since this question does not give specifically what is the reactant and what is the product, so I'm just going to label, okay, here is my reactant, okay, and then here is my product. Okay. So here, if the question gives specific species, then you have to write down here lah. Okay, next what we have learned, here we have mentioned that EA forward is from the reactant to the tip. So reactant to the tip here. Okay. So it's not the from here, from the reactant to the product. So this is not the EA forward. So the EA forward is this one. So whereas the activation energy reverse is from the product to the tip. So from product here to the tip. So here is actually our EA reverse. Then between our reactant and the product is our delta H. Delta H. Okay. So what about the top here? Okay, so the top here is actually, again, this is what we call the transition state. During your syllabus, you don't have to learn, but then just fill in your diagram. This one you will learn in detail during your semester 4. Okay, here we call transition state. But then here we have one more space where we haven't labeled it yet. Okay, so what is this? This is actually you're gonna learn during your SAS semester 4. Okay, but then just label it here. The name is transition state. So dia punya translation adalah fasa transisi. So transisi apa? So right now reactor ni kan, okay, so it does not sure that it will become product or not. Dia tak pasti lagi nak jadi produk ataupun tidak. So transition state ni adalah fasa dia tak pasti, sama ada dia energy dia cukup untuk turun bukit ni, ataupun kalau dia tak cukup dia akan patah balik dekat tempat asal dia lah. So ni fasa tak pasti. So this is what we call transition state, but then you will learn in detail during your SAS semester 4. Okay, so that is for exothermic reaction. For the endothermic reaction, since heat is absorbed from the surrounding, energy of reactant is lower than energy of product. So when you draw the energy profile diagram, again, reactant must be lower than the product. So I'm just going to label these two with the reactant and the product. Okay, and then I'm just going to label at the tip here. I've mentioned about tip ni kan. So that is what we call just now transition state. So next, let us label the delta H, the EA forward, the EA reverse. So delta H is between product and reactant. So let us check which one is between the product and the reactant. Okay, the blue one here. So between the reactant and the product, we label it as delta H. Next is EA forward. EA forward is from the reactant to the tip. So reactant to the tip. Okay, it's this one. It's not. This is product to the tip. So the reactant to the tip. So this is the EA forward. And then what we have left is the EA reverse here. So this is the energy profile diagram for the endothermic reaction. For the energy profile diagram for chapter 1, okay, where we have included the activation energy. So when you're drawing it, you have to label lah EA forward, EA reverse, EA forward, and EA reverse. So again, how to label it? So please take into account this one lah. Okay, if we have any calculation question, then you have to use this formula. Okay, so that is all the video for 1.2 collision theory.